There's a lot of things to love about Git. One of the things that I love is the fact that it's so easy to install. There's no long list of prerequisites for Git. All you need is a modern operating system, and by modern, I mean like Windows 10 is fine. All you have to do is head over to a search engine and type in download Git. Don't get fished. The first link you get should be gitscm.com/downloads, and there's the option to just download Git. I'm going to download Git for Windows because I'm running Windows 10 here. You'll get a couple of options. Is it 64-bit or 32-bit? I'm pretty sure you're running on a 32-bit operating system. And after you click it, well, it'll get downloaded, and it's just an exe file. And all you have to do to install Git is just run it. And really, you can accept all the defaults. You don't have to get too complicated in what to select. Now, I've been working with Git since there were only 2 screens on the Git installer. Where do you want to install it and finish? There's a few more options these days, and I'll point out a couple that might be interesting to you. But honestly, if you just want to get Git installed quickly, you can just click next, 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 next. It will install and your life will be fine. So here we are, installing Git with the GNU General Public License. You know, this was built by the Linux Foundation. Linus Torvalds wanted to have their own source code management tool that could manage distributed Linux across the world, and they built it. So really 2 great software products from Linus Torvalds. It's Linux, obviously, and Git. Now, it asks you where you want to install Git. Install it wherever you want. I don't care. I actually install everything into _tools, and then I don't like having uppercase letters in any path just because I've written so many scripts where that messes them up. So I just put it into C:/_tools/git. Put it anywhere you want. Doesn't matter. I know where it is. I can find it. Life is good. So number of options to select. As I said, just a few years ago, I think there was like only 1 or 2 options when you installed Git. Now there's a plethora. You can just accept the defaults here. It'll install Git Bash. It'll install a nice little Git GUI tool. Just accept the defaults and click next. Do you want a start menu folder? That's up for you to decide. I'm going to accept the defaults here as well. Now, here is one setting that I would highly, highly, highly recommend you change, especially if you're new to Git. When you have a merge conflict or something and you're using Git, you have to provide some notes, or when you do a commit, you have to put in a commit message. And Git will bring up Vim, and Vim scares the life out of most new developers and seasoned developers like me. I have spent a great deal of time trying to figure out how to exit Vim. It's :Q, by the way. I think it's :Q. Anyways, one of your options here is to replace Vim with something like Notepad++ or just Notepad on Windows. I promise you, your life will be so much easier if you change it to Notepad or Notepad++, because you won't have to fight a text-based editor that is very intimidating for people that are new to software development. And it intimidates me. I've been doing software development for 20 years. So I'm not going to choose it because I'm just going to choose the defaults here. But that is my advice to you. It's going to ask you a little bit about whether you want to use the name master or main. It's a good idea to change this to main. If you're going to be working with a lot of old repositories, you'll see the golden branch, the pristine branch, the master branch named master. We are very much getting away from the verbiage of master-slave terminology. We now call it the main branch. You can call it whatever you want. If you're just having fun, you can call it the golden branch. Main is kind of the vernacular today. So I would suggest changing this to main. Now, I'd also let you know that if you're using some continuous integration tools like Jenkins, Jenkins actually looks for the name master, so sometimes it throws it off. But on the other hand, the progressive people at GitHub, if you create a new GitHub repository, the name of the repository is main. So I would make that change. You can always change it back later too, but leave that as main. Do you want to adjust your path? Accept the defaults here so that Git can work with third-party software real easily. Again, another default you want to keep. Keep it bundled with OpenSSH if you want to do some SSH handshakes in order to secure your local connection to the remote GitHub server. Again, accept the defaults. Use the OpenSSL library. Accept the defaults. What's the checkout style? Sometimes you can run into trouble if, some people are using Unix, other people are using Windows, and, some people use a /, others use a / in their folder names. Git will take care of managing the differences between platforms as you go back and forth, so those issues go away. So again, do the checkout window style, commit Unix style, so that way your Unix developers and Windows developers won't run into trouble. So again, just accepting the default, use Minty, accept the default. Here it's asking how to merge branches together. You can really streamline your Git commit history if you allow Git to do fast forward merges. It flattens out the commit history when nothing very exciting is happening. So that's a safe parameter to use as well. Also, do you want to use Git Credential Manager? This can actually help keep track of your username and password when you're connecting to external services. So again, leave this alone here. Enable system caching. Why wouldn't you want system caching on? That's fine. Avoid the experimental features for now, and then just click install. And boom, all of a sudden, Git will get installed. So there you go. That's how easy it is to install Git. Now, once this is done, I want to show you a couple of configuration settings that you have to do. Otherwise, you could get in trouble when you do your first commit. And I'd also just like to show you how Git actually does the key things that it does. Git really only does 3 things. It can help you manage a commit history. That makes it possible for you to save the state of your workspace, save the state of what you've done so that you can go back to it if you really mess things up. It's just like, clicking save every once in a while as you're writing a Word document or something like that. Although I think Word auto-saves. Git doesn't auto-save yet. It allows you to develop in branches, and branches allow developers to do isolated development. So if they mess something up, none of the other developers know. And it also allows you to do collaborative work. So it allows you to go to GitHub and pull changes down from GitHub and make some changes and push them back up. But those are the only 3 things that it does. Manage a commit history, allows people to do isolated development in branches, and allows people to work collaboratively in a distributed environment around the world. So those are really the 3 key things that Git does. And if you master those, you've mastered Git. I've got a bunch of tutorials on how to do that. But I'd like to show you some of the basics of it after we've done the install. So do you want to launch Git Bash? I'm going to say no for now. But if you're going to be doing some work with Git, you're probably going to want to get familiar with Git Bash. We'll bring that up in just a second. But I'm going to click Finish there. Git comes up, gives me some release notes. That all looks good to me. I'll close that window. I don't know why Edge came up there because I thought Chrome was my default browser, but there you go. Okay, so what's next? You've installed Git. How do you know it's installed? Well, what you do is you work with Git a little bit. And here's what I'd like to do. I would like to just create a new theoretical workspace for creating an application, creating some code. It sounds like a big deal. I'm just going to create a folder and put some files in it. And then add a couple of files to Git. Just show you how easy it is. So I've got my C drive right here, and I'm going to create a new folder on this C drive, and I'm just going to call it _repos. That's it. So I created a folder, called it _repos. Life is good. I'm going to go into that folder and I'll create another folder. I'll call it my first repo. I guess I probably could have just created a folder called my first repo, but I always create a folder called repos on every computer I have, and then I always get clone into that folder. So, but I create a folder called repos, create another folder called my first repo, and if you didn't guess it already, I'm going to create a Git repository here, a place where I can create files, I can edit files. You always associate Git with code, but it can be any type of file. And I can have Git keep a history of all of the files that I create. So how do you do that? Well, you can just right-click on any folder, and notice a couple of options have come up. One option is Open Git Bash here. Another one is Open Git GUI. Git GUI is a great tool to help you work with Git. It gives you point and click Git functionality. People that want to look, really advanced always open up the Git Bash shell, Bash born again shell. You're not really supposed to say Git Bash shell because the SH stands for shell. It's equivalent to saying the Git Bash shell. But anyways, I'm going to open up the Git Bash shell, and that's opening it up in this folder. And you can see the Git Bash shell says that I am in the My First Repo folder. Now I am going to increase the font here, so give me one moment to do that. Okay, that looks good. So I've opened up the Git Bash shell in a folder named My First Repo, and I'm going to create a Git repository. So I just do this. I go Git init standing for initialization, and it says, hey, I just initialized a folder to be a Git repo. It even says I put a special folder in here called .git, and it's like, no, you didn't, but it's actually a hidden folder. So if I come over here and I say View, Options, Change Folder Options, go in and say, hey, show all of those hidden files. Click Apply, click OK. When I come back in here, View, Options, Change Folders, Show Hidden Files, Apply, OK. Now we can actually see that .git folder. It's a little opaque. That means it's a hidden folder. Now you don't have any reason to go in there. That is just Git. If you actually deleted that folder, you'd be deleting this Git repository. I'm going to live dangerously. I'm going to dig in there. You can see config, hooks, objects. This is actually where Git keeps your commit history, keeps track of GitHub, Bitbucket, GitLab repositories you might be connecting to. All of the configuration stuff is in there, the history of all your commits. As I said, leave that folder alone, but it just gives you a good warm feeling to know that it's there. Now, what do you do with Git? Well, the idea is you just, you start creating folders or create files, right? So I'm going to create a new file. I'm going to call it alpha.txt. I'm going to create so a new file has been created. One of the things you can do is you can say to Git, hey, what do you think about my folders there? Do you see anything interesting there? Control L clears the screen, and I'll say, Git, give me the status on that current folder. And Git comes back and says, hey, there's a new file in here. I'm not paying attention to it. It's untracked. If you want it to be included in a commit in the future, tell me to put it into my index of things to include in the future commit. And I'm good with that. I want to make that part of a future commit, so I'm going to add that to what they call the Git index. And the way you do that, Control L to clear my screen, you just say git add, and then the name of the file, alpha.txt. And so now I've said to Git, I said, I created a file. The next time I do a commit, I want this file to be part of the commit. Maybe you can create multiple files and then make them all part of a common commit. People say, what exactly is a commit? And I always say, a commit's like a save point. It's like you're playing a video game and you get so far in the video game and you hit a save point and then you keep going and then you die. Well, you don't have to start at the beginning. You can go back to that save point. And that's what a commit is like in Git. It's like a save point, a point that you can always go back to. The other cool thing is about these save points is you can share them with others. You can push them to a GitHub, GitLab, Bitbucket repository, and anybody else that uses that repository, well, they can pull them down and see your commit. So you can share it with people too. So that's the idea of a commit. Now, here's the thing. After you've added a bunch of files to the index, you can do a commit. But the very first time you do a commit, if you don't configure your username and email address, you're going to get hit in the head with a hammer. And that's because every time you do a commit, you're supposed to tell Git who you are and how somebody going through the repository could contact you, and that's through your email address. So every single commit you do gets your name and your email address on it. Now, don't worry, you're not getting added to a newsletter. You're not going to get emails from git.org or Linus Torvalds. It's just using the Git repo. And if you never move your repo off your local machine, no one else would ever see the username and password on there. And you can just put a garbage, not password, email. There's no password. You just put a garbage email on there if you want. I'll show you the issue, right? Because like we're all excited, and this is the funny thing about Git. I said there's lots to love about Git. The one thing I don't like about Git is the first time you do a commit, and you say, hey Git, I want to do a commit, right? I want to create a save point. -m says I want to add a message here, and then in quotes I could say my first commit, right? End the double quotes. Now this is going to error out on me, okay? This is going to cause a problem, and it's going to say, I don't know who you are, and I don't know your email address. And you can't commit to this Git repository until you've told me your username and email address. So you have to do these, I don't know, I think these are fairly cryptic commands. You got to do git config -- global. Global means you can do this just one time, and then you don't have to do this every time you create a new Git repository. You could do local configurations too. But you can use user.email. And I'm just going to say, me@example.com. Like it doesn't go anywhere, right? I want to just avoid any fear that like you're going to get on some mailing list here. And then git config -- global user.name. And my name's Cameron McKenzie. I'm the editor-in-chief of the serverside.com. Head over to the serverside.com for lots of Git tutorials. I forgot to introduce myself earlier. I hope you forgive me. Okay, so now I've configured my email and my username. Now I can do a commit. So git config, so I can do a git commit. And if I click up, if you click up in this tool enough times, it'll take you back into your history. I'm going to click Control L just to clear the screen a little bit there. And I'm going to do my first git commit. And boom, there you go. I got a commit done. Now I'm going to create another file over here. I'm going to create a new text document. I'll call it beta.txt. When you're working with Git, you always think it's going to be an HTML file, a Python file, a Ruby file, a Java file, a Kotlin file. It's like Git can keep track of anything, right? Like you want to maintain a source code history, Git can do it. It can track any files, images, stuff like that. You don't want to put big files in your Git repository generally, but it can do it. Okay, if I could do it, a Git status now. Notice it'll say, hey, again, there's got a new file, so that's beta. I could also go into alpha and make an edit. Hello, Git world. We just installed Git on Windows 11. Okay, now I'm going to click Control L and do a Git status again. And so now it's a little different. It's saying, hey, you've got an untracked file, a brand new file, and you've got a modified file. And none of these are going to be part of the next commit because you haven't added them to the staging index yet. You haven't added them to the list of things that you want included in the next commit. I'm going to click Control L to clear that up. But one of the things you can do to just add everything to a commit is just say git add dot. And a dot is kind of like, everything in this folder and subfolder. And now if I do that git status command, it says, you've staged 2 files. Nothing's untracked right now. And if you do a commit, the fact that the changes to alpha will be included, and as well the new file beta will be included. So why not do that? Git commit -m. What is that? Second commit. Git status. Nothing to commit. Everything's done. So there you go. That gives you, an idea of how to work with Git. That's how you do the basic configuration, how you add files. So that kind of gives you a basic look at how you can manage the commit history. Now, there's another cool tool here. So you notice that if I right-click, there's also something called the Git GUI tool. And so I'm going to open up that Git GUI tool. And here it is. It looks like it's in my first repo over there. So there's the Git GUI tool. Now, look at this. I'm going to create a new file over here, a new text document. I'm going to call it charlie.txt. Let's see, come over here. Jeez, I thought that it would have found that file. Maybe I have to rescan. And as soon as I rescan, now the Git GUI tool is saying to me, hey, you've got some unstaged changes. And it's like, oh, do I? It's like, yeah. Okay, well, let's add those to the index. So you double click and it now stages that file. So this is doing the same thing as the git add command that I did before. And it says you have a commit message. I'll say this is the third commit, right? Click the good old commit button. And it says, hey, you now have 3 commits in your history. So this is the Git GUI tool, and it allows you to do all of those neat things that you can do with the command line. I think most of the things you can do with the command line, certainly all the Git porcelain, all of the high-level commands that people use in Git is referred to as the porcelain, and then there's like really low-level stuff. They call that the plumbing. But that basically, gives you a nice tool for doing all the major things you need to do with Git. There's also this cool visualize history. So if I say visualize mains history, you'll end up getting this nice tool that comes up here. And you can see it's actually giving me a little visualization of the history. You can see those 3 commits. It even gives me the commit ID of each of these commits here. Just a real, you can see the email and username of the person that did the commit. That's why you do that git config. It's just a real nice tool that allows you to view the history. Once you start getting into a lot of merges and a lot of commits, you can end up having a really rich commit history. So that's pretty cool. Now, after you've done that, one of the other things that you might want to do is, just maybe clone something from GitHub, right? Like if you're using this tool, you're probably working with GitHub. So I'm going to go to github.com/CameronMCNZ. And let's see if I've got any repos up here. Looks like I got a number of handsome ones. And one of those repos is a Spock Lizard Docker repo. How could you not clone that? So this is a repository that I've got up on GitHub. It's a public repository. Anybody can see it. And if you join a team, it's very, very likely that they'll say to you, hey, the code for the application is up on GitHub. Why don't you pull it into Eclipse or pull it into VS Code or IntelliJ or whatever IDE you're using, or even just pull it down onto your local file system. And when you take code that's up on the server and bring it down, that's called a clone. When you create your own repository, that's an initialization. If you pull code from GitHub, GitLab, code commit, that's called cloning. But in order to clone a remote repository, you need the remote repository's URL. And so if you click the beautiful green button there, you actually get the URL of the remote repository. So you can see, github.com/CameronMCNZ, Spock Lizard Docker. I would just say copy that. Now, my copy and paste skills are horrible. So I'm going to copy that a million times. I'm going to click that super hard. I don't know why. My copy and paste always messes up. And what I'm going to do is I'm going to clone that repository, right? So I'm going to take that repository. You can see it's got cool files on it like Jenkins file, Docker file, this.html, POM, and then it's got a source file with all sorts of crazy Java code in it. I'm just going to take that URL from that green link, and I'm going to head over here. I'm going to close my Git GUI tool. I love Git GUI, but I'm going to close that up. By the way, I got a couple of tutorials online about some other Git tools as well. There's Git Kraken, there's SourceTree, GitHub Desktop is another really, really popular one. So I always recommend people, it's good to know the command line, but at the same time, it's also really good to have a tool that can simplify a lot of the Git stuff for you. Now I'm back in that repos folder. I'm not in the my first repo folder, right? That's already a Git repository. You see that .git there. But the repos folder is just a folder that can contain other things. And what I'm going to do here is I'm going to open up that git bash shell, and I'm going to issue a clone command. I'm going to type in git clone, and then I'm going to paste as I issue this, I want you actually to look in that repos folder right there. So I'll move this over just a tiny bit. And as I do this, you'll see a new folder get created. You'll see that Spock Lizard folder get created on that file system there. So I'm going to click enter. So it's cloning into Spock Lizard Docker. It's a big repository, so it might take a minute or two. Okay, so it says it's done. I'm going to close that window there. You see that the Spock Lizard Docker project has been cloned, and now it is down on my file system. So that repository, that application that was up on Docker Hub, not Docker Hub, up on GitHub. Boy, we're getting ahead of ourselves with Docker stuff. Yeah, take a look at the files in here. Yeah, and there we see up on the server, we see files like Docker file, Jenkins file, declarative pipeline, Maven, POM, this.html, SRC, Target, Walmart. No, sorry, there's no Walmart there, only Target. And it matches all the files on my file system. So now I've taken that code from the remote server and I've pulled all of that code down. Now the other cool thing is you can see that there's a bunch of branches on the server. You know, there's patch 1. What's that one down at the bottom there? I can't even see it. You can always, switch branches when you are working with Git. And I'm going to open up a Git bash shell here. I'm going to move this a little bit so that we can see the folder system. But I'm going to go, I'm going to type in git branch -a. That tells me all of the different branches that are part of this repository. A branch is a place where you can do isolated development, take chances, do things on your own. Boy, that is a lot of branches there. Control L to, okay, now I see I'm stuck in VI. I can't get out of here. I'm clicking enter, I can't get out. I've got to click colon and then Q. Now it gets me out. Always messes me up. But yeah, so this shows you like all of the branches here. Now that's like too many branches, but you can see that there's a branch called master. There's a branch called PRF. I'm on master right now. I could switch to that test branch. So I could say git switch test, and boom, now I've switched to another branch. But you'll notice that all the files on the right-hand side there change as I move from one branch to another. Branches, as I said, are places where developers can do things and take chances and experiment and break things. And if what a developer does on a particular branch fails, doesn't work, well, they could just delete the branch, right? And if they do something that they like, they can merge that branch into the main branch or the master branch. So if they like what they accomplish, they can share it with people. So it just encourages people to test, take chances, things like that. So for example, I'm on this branch called test. You can see the name there, test. So I'm on this branch test, and I'm going to create a new file. I'm going to call install git on Windows 11. I'll just call it install git on Windows. Okay, so I've just added a file to this repository, which is in the branch test. And I can say git add, just like normal, and I can do git commit -m, and I'll call it the install git on Windows 11 commit. I don't know, that's a long name. But now I've made a commit, and I've now got this file, install git on windows.txt, as part of this branch. Now, watch if I do a git switch and go back to master. Now notice this was pulled down from GitHub. That's why this one has a master branch and not a main branch. But watch if I switch back to master, which is what I cloned down, you'll see that install git on windows.txt file goes away. See, so now I'm on master branch and that file disappears. If I go back to the test branch, git switch test, It's like I'm David Copperfield. All of a sudden that file comes back. And so this is one of the things that branching allows you to do. It allows developers to work in an isolated space and take chances, write code, maybe break the build. And if what they do they don't like, well, they can delete it. And if what they do like, they can actually merge it back into the master branch. So I could do a git switch back onto master. Now I'm on the master branch and I can say git merge test. And so you notice that on the master branch over there, we don't have that install git on Windows txt file. But if I merge that test folder into master, it would come in. Now, just as I'm doing this, I'm thinking this is a very bad idea because I have no idea how out of sync that test branch is with the master branch because I haven't touched this repository for a long time. So if things are really badly out of sync, you can get a merge conflict. And it's way too early in the morning to be dealing with merge conflicts. But if everything worked out, you could do a merge, and that would bring the two files together. And of course, it's not get merge. It would be git merge. I spelled it G-E-T, git merge test, and it would bring them all together. Okay, and so again here, this is in VI. If you weren't in VI, if you were smart and you actually used Notepad as an editor, you would be fine. But right here, I've got to actually go in here and type something in for my commit message. And I said, looks good. Wanted the install git on Windows file, whatever. And then to get out of here, you just click escape, :X, hit enter, and then your files are merged. And you'll notice that now I'm on the master branch, and I've actually got the install git on Windows txt file sitting right there for me. So you can see that I've actually merged things together. The other cool thing you can do after a merge is you can go into the Git GUI and say repository, visualize all branch history. And it'll actually show you the point where master and test got merged together. So you can kind of see that merge point in there. But this will actually go through an entire commit history. And for some repositories, this can be pretty impressive. So this kind of looks a little bit like the Paris subway system at a few points in here. So that's all super cool. But yeah, and there you go. So, I mean, if you think about it, what did we do? We installed Git. We installed Git on Windows 11. Then we did some configuration. We configured our username and our email address. We added files to the index, and then we did a commit. After doing the commit, well, we opened Git GUI, looked at the commit history. Then we thought, hey, really, it's not just about a commit history, but doing collaborative stuff like pulling from remote repositories. So we cloned a remote repository. And then in that remote repository, we actually did some work locally. And now, by the way, that install Git on Windows is local. But if I was actually to go over to GitHub and looked at the files on GitHub, you notice that GitHub doesn't have the install Git on Windows. So everything that I've done so far in this repository I cloned is all local. In order to get these changes up to GitHub and share them with other people, I would have to take those files and push them up to GitHub. And then after you've cloned something for the first time, you want to get changes and bring them down, you have to do a pull or a fetch. Pushing to GitHub would require some credentials, so I don't want to get into that. But I'd have to log into GitHub here in order to add some files. I think that's all some stuff we can cover in some future courses. But I mean, we covered a lot of the basics here, even taking a look at branches and how we can create code in isolated branches and merge branches together. So I think overall, that's a pretty good look at how Git works, especially considering you may have only just watched this video because you simply wanted to download and install Git on Windows 10 and get things working. Anyways, before we depart, I just wanted to mention a couple of things. First of all, I mentioned earlier, my name's Cameron McKenzie. I'm the editor-in-chief over at theserverside.com. We've got lots of great tutorials on Git, DevOps, Maven, Jenkins, Java, Python, JavaScript, Node, Agile, Scrum, you name it. So head over there, take a look at what we're writing about over on the serverside.com. Also, I'm an author. I wrote a couple of books. I wrote Pickering is Springfield. It's all about how the town of Springfield in The Simpsons is actually based on a small town in Ontario called Pickering, just outside of Toronto. So, for example, the highway that goes through Pickering is the 401. The highway that goes through The Simpsons, the Springfield and The Simpsons, that's the 401 too, which is weird because American cities don't usually have 400 highways. They have interstates. So check that book out, Pickering is Springfield. Also, I'm a Java guy, so I wrote a book called Hibernate Made Easy, all about Hibernate and JPA. Check that out too. Might have some books on Git and Spring coming out in the future. And also, I've been working with a young freelancer over on the server side. You may have seen her on Twitter. She's got about 300,000 followers, at Scrumtuous on Twitter. She wrote this great Scrum Master certification guide. And if you're interested in Scrum, if you want to be agile and maybe you want to advance your career and get a product owner or Scrum Master credential, I can't recommend this book enough. So head over to Amazon and pick that up. If you're interested in my personal antics, I'm on Twitter as well. At CameronMCNZ is my handle. That's my handle on GitHub as well. I think that's also my handle on YouTube. And, I'm going to do the standard grovel where I ask you to subscribe on my YouTube channel.